going. All right, so we got $5,000 invested at 13.93% annual percentage yield from November 84 to November 2021. So first thing we ought to figure out is how many years it was invested for, and you can just go 2021 minus 1984, and that'll give you 37 years, right? So it's invested at that amount of APY for 37 years, right? So we can just use the compound interest formula, because this is going to be compound interest. You know, when you make interest on that, you can get more money on top of it the next year. I'll just do a couple of years just for fun. So 1984, we begin with $5,000. We'll just put the balance here. I'll just do a couple just so we can all see how this thing works. 1985 is 1 year. And so you just go 5,000 times 1 plus, and this as a decimal is 0.1393, right? So I can go 1 plus that, or just 1.1393, and that'll be the amount after 1 year. $569.5, 5696.50, right? So we got $696 interest after the first year, and that goes back into the fund the next year. So the next year, 5696.50, and again you multiply by 1393, or sorry, 1.1393, and we get what we have at the end of 1986. So this is how the thing works. It's compound interest, not simple interest. So and it's just at the end, this is the yearly return. So this is how we would calculate the annual return. So it's like annual compound interest, right? So that number times 1.1393, and now we have $1,490.02 in the fund. And yeah, it's going up pretty quick, I guess, but definitely. So let's get our compound interest formula going. And again, we can remember, well, for 1 year, you go 5,000 times this. That was for 1985, 1 year. For 1986, you just do it again, times 1.1393 again. And so 2 years later, it's going to be the compound interest formula like this, 1393 to the power of 2, right? And so the only question is, for 2021, it'll be what? 5,000 times 1.1393 to the power of, and that'll be 37 years, right? So again, it's just the compound interest formula, the principal times 1 plus the rate to the power of t, right? And so plugging that in the calculator, it's 5,000 times 1.1393 to the power of 37. So you can plug it in that way. Other students like to do it with the plus in there. It won't matter. Just keep it in parentheses if you're using a plus. Then to the power of 37. Your calculator understands PEMDAS. So it's going to do what's in the parentheses first, and then exponents, and then multiply, right? And even a third way to do in a calculator is to go star for multiply for 5,000 times. But if you do that, you must do 1.1393 to the power of 37, right? So any of these three ways, whichever you prefer, 1.1393 to the power of 37. And we should get 623,131, right? But rounded to the nearest $1,000, 623,000. Is that okay? Which is kind of something else, and so that begs the quote, it takes money to make money, which is a bit cynical. That's one way of making money for sure, is to just have money and just invest it. And that's kind of that was kind of easy. You didn't have to be a landlord, you didn't have to collect rent, you didn't have to work, you didn't have to do anything. You just had to leave $5,000 in this fund, and 37 years later, you've got a small... Geez, you got yourself a lot of money there, right? So anyway, but that opens up discussions of, well, who has $5,000 back in 1984? It's kind of that's a pretty big sum. It's probably the equivalent of something like 20,000 in today's money. And who has that type of money to just sit and not do anything with, you know? And so that's part of it. It's like, because you've got to pay your bills and, you know, all that sort of stuff. So who has that type of money to just leave in a fund all those years? And anyway, so but there you go. That's one way of making money, is to just already have money and leave it in one of these funds, right? So there you go.